Hi guys, welcome to a new session. So we'll begin another topic which is related to the topography map, and the topic is methods of representing height in a topographic map. We have already studied one method, that is contour. We studied this in detail. So other than contour we have few more methods like spot height, benchmark, triangulated height, and relative height or depth. So these are the four remaining methods to be studied. So these are the various methods which we use or which are used in a topographic map to show height. You are familiar with the contours, right? So contours are shown or drawn using brown color, and every fifth contour, which is called as index contour, is highlighted, and the height is written on that one particular contour. So here you can see the examples: 400, 300, 300, 400. So you can find out the height of these places, sorry, these contours, by looking at the value written on the contour itself. So I'm skipping very fast. We have the next one. It is called as spot height. So as the name suggests, it shows the height of one particular point. If you see this map, here we have one spot height. There is a spot here in the middle, then it is written 522. Then here we have another one, the spot is there, then 4338 here, another one. So this is what is called as spot height. So height of one particular spot is written, and that is what is called as spot height. And here you can confirm it. We have contour valued 400, this one. Then the next index contour is this one, that is 500. Contour interval is 20, so this would be 520. Now there is no other contour, that means the height is between 520 and 540. But in this case, height of this place is measured exactly, and the height is 522. So spot height is used for showing the exact height of any places. It shows height of one particular point, not the entire region, height of one particular point using a spot and a number. And the conventional symbol for spot height is this one, right? First there will be a spot, right, a small dot, then beside that the value is written. It shows the height in meters, height of a place, height of one particular place above the mean sea level. And the features are like this. It shows the exact height of a point above the mean sea level, and it is indicated on the map but not on the ground. So if you go to that one particular place, you will not get any details about the height of that place, but it is shown only on the map. Now another thing, the method to show method of representing spot height is, it is shown using a dot followed by height. So I think that is very easy. Now another important thing about spot height is, it cannot give any idea about the relief features, like what is the slope, whether it is a mountain, whether it is any other kind of landform. It only shows us the height of one particular point. Now the next method to represent height in a topographic map is called as benchmark. In some of the maps you can see benchmarks. It is given like this. It will be written BM in capital, and followed by that there is some values. So that shows the height of that one particular place. So in this example we have benchmark 225.3 and 224.6. That means height of these two places are 225.3 and 224.6 respectively. Now the symbol for benchmark is this one, the capital letter B and M followed by the value. So that value indicates height of that place, again above the mean sea level. Now it is actually etched or engraved or written on a stone or on a building, right? So if you go to a place where you can see benchmark is mentioned in a map, you can actually see it is written on the ground over there. So it shows the exact height of that place, and it's not only that, it shows the exact height of that place including the height of the object on which it is written. So imagine if it is written on a concrete structure, and that structure is 1 meter height. So the height shown there includes the height of that concrete structure also. So this is one example. Here you can see we have a concrete structure here, a small pillar like thing, and it is written, so many things are there, GTS, that means a Great Trigonometric Survey. So the survey which conducted for preparing topography maps are called as great trigonometric survey, because they use the method of trigonometry for finding out the height of many places. So triangulation method, you might be studying it in mathematics. So here it is written standard benchmark and the year 1907, and if you see read this one carefully, it is written the height of this pillar is 1020.7 feet. It's not that clear, but I can read from here. That means height of this pillar is 1020.7 feet. That means the height of this place is slightly less than this one, and the height of the this height includes the height of this pillar also. So this is what benchmark. So it is either written on a stone or it is etched on a concrete structure like this. So this method of representing a height is called as benchmark. So these heights are used by surveyors. Later when they come to the same place, they can use this as a survey stone for surveying purpose. That's why benchmarks are created. We have another example here. Again same thing, GTS, Great Trigonometric Survey, standard benchmark, and the year is given 1905. Maybe here in the bottom the height would have been given, but we cannot see it from here. So this is how benchmarks look like. So they are permanent. They help surveyors in finding out height of other places by taking this as a survey pillar. Now imagine we have a small hill here, and above that we have a benchmark. So the height is like this, the same thing which I told you in the previous slide. So imagine the height of the mountain is 100 meter and height of this pillar is 1 meter. Then on the benchmark it will be written as 101 meter. So including the height of the pillar, the total height is written with the help of by adding two capital letters B and M, that shows the benchmark. So this is how benchmarks are written. And the third method, the fourth method is called as triangulated method. So this is shown using a triangle followed by a value. Right, you can see this in many parts, in several times in the map which we are using. So it is called as triangulated height, and the conventional symbol for triangulated height is a triangle followed by a value that shows the height above mean sea level in meters, and it is the height of a point determined or calculated trigonometrically. That means it is not accurate, it is calculated without going to that one particular place. Imagine the case of such steep peak. Sometimes surveys, now you have to keep in mind, all these surveys were conducted many years back in 1960s or 50s or before that. So at that time it was very difficult for the surveyors to move through all those difficult terrains. So sometimes it was very difficult to reach the top of peaks and other terrains. So in those cases, trigonometry was used for determining the height of certain peaks and all. Right. So here whatever they get is the height they get by doing trigonometrical calculations. So the height may not be accurate. So that's why triangulated heights are not accurate. They may be more or less same with a very little percentage of error. So again, unlike benchmark, it is not shown in the ground, it is shown only in the map. And the last one is relative height. Relative height shows height, or sometimes it can show the depth of a place also. So that is not the actual height from the mean sea level. So it is the height or the depth of a place in relation to the surrounding area. Now the conventional symbol for relative height is a number followed by a small letter r. It will be written most of the time in black color, or sometimes it can be in blue color. So if you see here, there are three examples given here. First one is a dot followed by 5r, then 17r, then a dot, and again another one, a dot followed by 20r, but it is given in blue color. So if it is given in black color, that shows the relative height of that one particular point, and if it is written in blue color, it shows the depth of that one particular point. Right, I'll take an example from the map itself. So here we have a map, and the feature that you are seeing here, the feature indicated using the brown dots, I think you remember, it is the sand dunes. And here you can see it is written 15r here, then 9r, 10r, 18r, and as I told you in the previous slide, sometimes the dot is written first or dot is made first. Here it is after the value it is given. Here again it's before the value, so it can either be before or after the value. So anyway, whatever it is, so if it is written using a small letter r, then that is showing the relative height. So all these shows the height of these sand dunes from the surroundings. So I think you can imagine a landform where there are sand dunes which are higher than the surrounding area. So if you could imagine, as I told, it will be somewhat like this, a desert with sand dunes here and there. So these values which are written exactly at the place of the sand dunes indicates height of those sand dunes. Here is one example. So if it is written 12r, that means the height of that sand dune is 12 meter. In other words, we can say the sand dune is located, or the top of the sand dune is located 12 meters above the surroundings in relation with the surroundings. So that is how we use uh, this particular concept called as relative height. But there's a tricky concept here, because the meaning of the r changes according to situation. So you have to be a little thorough with the concept, then only you will be able to identify the meaning of r clearly. So here we have one example. So if you look into this one particular feature, what you can see is a black color circle with few dots inside and a feature outside that. It's drawn using some lines, and the values written 3r outside that feature. So this one particular feature, I think you can recollect. So this is a dry tank, right? And it is dry. So the reason it is dry is it is shown using black. So that we can say it is dry. And this one particular feature shown using a small tiny lines is called as an embankment. Otherwise, it's something like a wall. You are familiar with this thing since you are living in the city with a lot of lakes, right? So this is what is called as an embankment, and this is a tank or a lake with embankment. So just beside the embankment it is written 3r. So here the meaning of r is different. So for those who don't know what embankment is, this is what an embankment is. So a bund, right? A structure which is constructed on one side of the lake to store the water is called as embankment. So the meaning of r in this scenario is actually the height of the embankment. You have to keep in mind the value is written outside the tank near to the embankment. That means the value indicates the height of the embankment, right? Again we have a similar situation, but here if you can see the value is written inside the tank, right? So value is written 3r is written inside the tank. Everything is same. You can see in the north side embankment is there, right? Very tiny. This is also a dry tank, right? It is dry, shown using black color. There is no water in this at this moment. And if you see there is a river joining, right, from southeast side. So on the other side there is an embankment. Now here also same scenario, but keep in mind the value is written inside the tank. That means the meaning of this 3r is depth of this tank is 3 meter, or this tank is 3 meter below the surface in relation with the surroundings. And remember, in the previous case it was written outside the tank near to the embankment, so that shows the height of the embankment. So this is what I told you. It is a little tricky. You have to observe it carefully, then only you will get the correct answer. Now another example. So if you see here is another map. You are familiar with this part of the map. So since you are familiar with this map, part of this map, we are going directly. So there are two r's given. One is 10r, another one is 5r, and next to this you can see a particular type of landform. Just try to recollect this landform. You might have seen this when you were studying these conventional signs and symbols. What does this indicates? Or this is the symbol. It shows a dam. Right. Now here the value, that is 10r, is written outside the, or outside in the sense this is the reservoir. So this is written in on the other side. So it is written next to the dam like this. So there is a dam and the value is written somewhere here. So it shows it is the height of the dam. It is not showing anything else. It is showing the height of the dam. So if it was written inside the reservoir somewhere here in this part, then that would mean it shows the depth of the water there. So according to the place where it is written, the meaning of r changes. Now another scenario is this one. I told you, if values are written in blue color like this, right, it is 12r, and next to that you can see a blue circle. That means a well, it is called as a lined perennial well. So a 12 are written near a lined perennial well means depth of the well is 12 meter, or that well is 12 meter below the surrounding area. So whenever it is written in blue color, we can directly guess that it shows the depth of that particular well. Now here again another confusing one. If you see this map, we have a dry river here, a dry river with a perennial water channel in the middle. So this blue color or blue line indicates perennial water channel. So we have a dry river here, and this black color dot indicates dry riverbeds, and this value 10R is written within the riverbed. So keep in mind, it is written within the riverbed, not outside the riverbed or not in the bank. So when it is written inside the riverbed, it shows the depth of the riverbed, or it shows the depth of river from the bank. Now another example, if you see this one, right, we have value written 5R, and next to that you have blue circle. What does the blue circle indicates? It shows perennial unlined well. So what do you think? Is it the depth of the well or something else? Make a wild guess. Good. Okay, good. So it's not showing the depth of the well. The reason it is written in black color. I told you it will show the depth of the water body or the well if it is written in blue color, but in this case it is written in black color. Not only that, when I shown the symbol of relative height or depth, I shown you that there is a dot next to that value. Here also we have a dot, right? So it is fully black in color, so it shows height of that one particular point. So it is written very close to the bank, right? So again the meaning slightly changes. The meaning is the particular point, this one particular point is 5 meter above the riverbed. So the meaning of R changes according to situation. So you have to practice this very well, right? Whenever you have a doubt, ask me, clarify it, then only we can go forward. So it will make a lot of confusions, but overall it is very easy. Only thing you have to observe the map carefully, right? So that's about for the day. So we have discussed these many things. Contours, you are already familiar with the contours. Then 4 new concepts: spot height, benchmark, triangulated height, relative height or depth, right? Now the main important the important thing, that is the questions for the day, right? So with reference to the appendix number 3 in your maps and topographic book, you have to answer the following questions. First one, find out the 6-figure grid reference of the following: highest point in the given extract of the map, then the deepest well in the given extract of the map. So locate these two first, then find out their 6-figure grid reference, right? Write the correct question numbers. Then second one, name the settlement pattern in grid square. Given grid, there are 2 grid squares given. You have to find out the settlement pattern. Then name the drainage pattern for the following. And the fourth question, name any 4 human-made features in grid square 1923. So look at that one particular grid square, just list any 4 human-made features that you can see in that one particular grid square. And the next one is another one question is this one: what does the following indicates? 3 are in grid square 2 3 2 2. Then red squares in 2 4 2 2, right? So without asking anyone, without taking the help of anyone, try to solve all this and keep it ready with you. I'll ask you to send this one. Thank you.